Hello and welcome back. Today I have a system multimeter and it is from HP and it's the 3437A and yeah, it's mostly used for data acquisition because it can do that very fast. It is old because it is from 76 or just a bit later. The manual is already from 78, I see. And it even comes because apparently there was a difference between the one from the UK and the one in the rest of Europe or America. Because it says here, be careful, after this in the serial number, you cannot interchange the circuit boards or parts because there is a metric model and an English model. So, not sure what that means. Hopefully it's only the screws. I have a 2-in-1 deal, so I got two. The status is unknown for both of them, so I like to test that. I will again change the power supply in the back, the voltage that it connects to, because usually with these older devices, even though it is already for Europe for 220 volts, we nowadays have 230 volts already. Since the last, I don't know, 10 years. But as I mentioned a few times before, I have a lot of solar panels around here. It is summer, the sun is full, so I am near 240, even 238 I see. So I will switch that over. And well, let's have a closer look first. Yeah, although both of them are the A version, the 3473A, this one also, there is a slight difference, and it looks, the display is slightly different. And yeah, what is a bit difficult for me now here, this is a triax BNC. Let me zoom in on that. Yeah, and those triax BNCs, I also had one on the Keithley current source, the Keithley 224, and probably it's also on the Keithley 220. But there, it only has a bayonet still of 2. Only the inside is double. And then you can use a standard BNC. Here I cannot do it because here I have a thingy, here I have a thingy, here I have a thingy. And here, the surrounding is really the earth or the guard. And I really need to use this second and the middle pin. So I cannot cheat by just taking here the outside and the middle pin. So I needed to look for those connectors. Well, I did find these connectors here. You can see there is an extra ring, and well, of course the middle pin is there. But I need to connect that second ring on the inside within the white circle. And then the outside you can use as a guard just to take out extra distortion. This is on the lower voltages. Finding these connectors can be very expensive, and if you buy them at Farnell or RS, I've seen them even with a cable, then you get this connector with the cable, and then it's around 100 euros or dollars. I think it's almost the same now if the dollar is not even more nowadays. But I found these on AliExpress, and then they are around 30, which is still a lot for one connector. But I was cheap and I looked a little bit more. Now I have 5 for 20. So I said, okay, let me have 5 because I can use them. Yeah, I will use them probably sooner. And now I have 5 for the price of 20 instead of 1 for 30. So, but probably it will be a challenge to connect these because I already opened, and in the picture where I bought it, it should have 3 little connections to easily solder it. But I already opened, and of course it's not the case. So I need to figure out how to do that. But they are quite big, I must say, because in the front, it just looks like half, it's just like a half rack size. So if you have 2, it fits exactly. But look at it, it is very deep. And in the back you have your external triggering, your HPIB, and also an input because it's a system multimeter. So there is also, and it's just in parallel with the connector in the front, same triac BNC also. And yeah, it's made for acquisition, so it can do its sampling very, very fast. If you just use it in the front, in the just local, then it does about 10 samples a second. But if you use it in ASCII mode, and it is, I think it's limited by the ASCII output to the GPIB, because then it does around 2000 samples a second, which is a lot. But if you use the compressed or packed ASCII mode, then it can do over 5000, I think 5.7 thousand measurements per second, which is just a lot. So this is really, really made for acquisition. Yeah, and I can't believe it, it's 40 years old, and with those sample rates, that's amazing. So, but yeah, let's just have a quick look. Do they even start up? Okay, I put the power connectors on it in the back. You can ignore this very nice kettling in the bottom here. I'm using that to kind of balancing everything on my desk. Okay, well, it is very noisy. It does start. It does seem to measure. There is a delay. I don't know what that means. This one actually seems to sample internal trigger, external, then it's waiting for signal, or on hold, it's not doing anything, or just a single sample. ASCII mode, packed, compressed ASCII, so it outputs a lot faster data. You can program it 0.1 volt up to 1 volt up to 10 volts, so it really measures low values and only measures volts. Okay, this one just as noisy, also seems to sample fine. Both sample. Okay, local, external, manual, 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 that works. Well, this is just the output that we can't see. Okay, let's try to get the voltage reference on it. Well, I need those 3 BNCs, and I don't have one connected yet, and we will look into that later. So, but I could already try a little bit. This one is high, so that could be that it's actually measuring something, and this is not. This seems, by the way, like it is polarized, and this one is not, because if I look in my glasses, it looks a little bit different. Well, this one does not. Okay, funny. This one is a lot better readable. Let me just put 1 volt or something. 800 millis. And if I put the center pin and the outer pin, well, it doesn't do anything because this is really the guard. So I need to try to. I see something moving. Wait. Okay, it does move, but it says it's like 250 millis. But I don't know how good this connection is. Also, so it does do something. What about this one? Center pin and shield. Not really. No. This one is not doing anything. This one is, but it is a bit low, so let me get a few more volts. 3 volts. Yeah, now it's too much. Yeah, it actually does says it 3 volts. This one works, cool. So this one actually does work, and now you can see that the shielding is really the shielding because it doesn't do anything. I really need to get to this second inside shielding thingy, and now it actually says it's 3 volts. Let me go lower. See how fast it goes. Bang, bang, bang. Perfect. Okay, that's cool. Now I'm glad I bought 2 of them because it was a very little extra, and then I would have the risk that that I just picked the wrong one. And now at least one is working, but it is only on the upper scale, so I probably tried to put too much voltage in, and it's spot on. It's super fast. Yeah, of course it's doing so many samples. And now I just wonder why the other scale doesn't work. So I just play a little bit more and then I try to connect the 3x. Okay, it did work, I just didn't connect it well. So the 1 volt setting also works. I put now 500 millis in it, and it just it is just a bit difficult to connect it well, but now it says 0.500. But it is good. Let's go a little bit lower to the 0.1. This should be like 100. Yes, it is 100 now. It also shows 100. It's just a little bit difficult to make a proper connection. But you can see it's 100 millivolts. So now I should be able also to go one lower. Yeah. Cool. So the one that looks the nicest, actually, with a nice display. I like the screen is just better. That one is broken. Maybe it was taken out of production before, and that's why it still looks better. But they don't look bad at all, both of them. Just needs a little bit of cleaning. It's normal. And of course this is always sticky. Before I blamed the smokers, but it seems that this is kind of final. And that always gets just dirty at some point and sticky. But this is very easy to clean with some EPA, and we will do that. So, well, let's open them both. I'm putting the first one on the table, and I see here a sticker when it was checked for last, and that was actually in 98. So over here, have a better look, and this is the one that looks a little bit better. You can see this one has been checked in 98 February. Let's have a look at the other one. Well, this one is the one that still works, and it's probably then taking out after some time, because it was still checked in 2013 and it's still working. So maybe after 40 years they thought, nah, maybe we need to pull it out. Well, they look exactly the same. It says made in USA on some of the stamps, and these kind of look like pivots, and here are screws, so I think we can just unscrew and then open it. I have not checked the service manual, and the manual that came with it, it was the paper one I was reading in. It is mostly about programming it, and there are not too many buttons on it, so I think I need to turn it, because I think this just opens like this. Yes, it does. Okay, let's have a better look. So I have the one that wasn't working, and look at this. This is very well designed just to work with it. Five volts, a big reference, maybe, I don't know. And here we have the whole circuit, and the input is, here is the input circuit, because it goes here. I can see in the front the BNC, it goes to the back, there it parallels, and then it goes back here to the front. So maybe there is, yeah, there could be a little break in the cable from the front to the back, because it goes front to back, and then it goes to the input. So that would be a very easy, quick thing to check. So let's focus on the one that is working. I somehow need to connect this triax because it didn't have those solder strips that I saw in the picture. So I think I'm just gonna try to solder this. So it is still kind of shielded. Will not be using the outer shielding. Will only be using the second shielding that we actually use, because this is, you have a negative and the positive, and then you kind of have the guard. And the guard I'm just gonna discard and just connect that little coax. So, and then we can do some tests to see how well the one that is working is still working. And then maybe in the end of the video, I try to make a start of the repair, or if you can even try to identify where the fault is. So let's see how this is done. So this is the outer shield, the guard. And that seems to be connected then to the top. So this is all the outer shield, and then we have here in the middle, but there is not really something to solder, but maybe it just pushes it on top. So I just connect the center pin. Yeah. Kind of a pity that it is not. So that one I need to have a connection to somehow. So if I solder this in the middle, then the outer needs to be somehow maybe it connects just like that. I hope it all goes through the hole. That would be nice. Yes, it does. Okay. Okay, then we need to think in the correct order. I think I will just solder first the middle pin and then see what we do with the rest. Okay, then we try to put this one. No. Okay, new try. Let's do it a little bit like this. Then I also forgot, it also needs to go through this one. So we try to do that. And then okay, that seems to be, of course it's hot. That seems to be stuck. Then this goes through here. Hopefully it still fits, because there is a little bit of solder on the outside, but it needs to, yes. Okay, I was able to push it in, and now I need to see how this will work in here, because it somehow needs to contact the without the rest. So what if I just do it like this and then cut it as short as possible? And then it just needs to fall on this edge, but not touch the outside. So maybe like this, just for a start, to see what it will do. There's not too much light. It needs to be a little bit shorter, but then it will push to that ring. And here it looks good. We push it a little bit more. Cut a little bit more here also. Yes, that looks good. Now it will push to the ring. Well, a good idea would be probably to just pay a little bit more and then have the proper triac PNCs. So it needs to be isolated from this one. That seems to be the case. If I get the middle, oh, let's get the outside. I have the outside. That is not connected, so that is not good. And the middle pin. The middle pin works, but the other doesn't. Okay. So probably it just fell exactly in that hole. Yes, it did. So I should try to keep it here. That is a silly system. Okay, so now it should be stuck. Isolated, yes. Outside. Yeah, inside. Also. And a short. No, okay, so it's connected. But it is not very convincing. That is a pity. Yeah, it's stuck. Okay, well, I should have thought about it before. Okay, let's see. Power it on. Can we see the display? No. I think now we can. It is very noisy. Let's plug this in. That seems to work. Let's get the DMC. Okay, then I have. Yeah. Yes. Okay, I tilted it a bit, and if we now go to 1 volt, look, 700. Cool. 6. And you see it's super fast. It is so fast. And let's go lower. I'm not sure if I can get this low with this one. Yes, maybe if I manually type. How did that work again? It does that. Even though it's to 0.1 volts, it still has this 2000 count, so if we go a little bit higher, it will probably, yeah, over range. That's interesting, because you suspect there this 1 volt is the maximum, but then it turns out it is still 2000 counts. And then there it goes. I'm amazed how fast this is. Puff. Nothing wrong with calibration, that's for sure. Well, that's very nice, it works. Doesn't have too many digits, and it is very noisy. But the whole idea with this system multimeter is actually that you use the output on the GPIB, and well, as I said, the sampling there is a lot more, especially when you use the packed mode. I think it was like 5,700 samples a second, which is crazy fast. So this is really that for processes that really change fast. I would not know how to set up this, that I can actually output the GPIB. But yeah, well, I will just start cleaning it. I did try a little bit with the delay, but most of these things you also control from the outside, also from the back. And yeah, I'm a little bit too lazy to find that out. But it's nice to know that this one is working, and I'm really, this sample is, oh, even on the screen, it's so fast. Puff, puff, puff. This meter is great for fast stuff. Well, let's get the rest of the copper salt. Just to clean it, not make it sticky, because it is still very sticky. Same on this side. They look identical, so I'm not that worried. No, they are identical. Of course, the feet are missing. That is like default with the HP equipment that you buy second hand. Yeah, and this is really sticky. So hopefully we can do that with an IPA. Let me experiment with the bottom first. Ah, yes, that goes. Now the stickiness is immediately gone. Remember to open a window, because it is alcohol and you will get a little bit dizzy if you don't. And I just bought this here in locally. This is from a local lab that produces this, and it also sells it. And if you bought 5 bottles, then you got a discount. So I did that because I already used 2 of my bottles, I think. And of course you need to store that in a safe place. And it works magic. Look at that. Maybe you should even use gloves that I don't do, so my hands will be super dry. And I already have problems with dry skin, so that's, yeah, what can you do? Look at that. That is like meal. Now I still have a few spots, and I have another cleaner also. That one is even worse for your hand, and it's a little bit harder to get because first I could easily get this one, and it is this. Well, the label is wrong, but it is a Tech Spray Defluxer Maintenance Cleaner. It's a 3-in-1, and it degreases, and it is great. If you have magic marker or something, this is the one to use. And also with this spot here, probably I just spray a bit, it will disappear. Okay, that looks so much better. I must say, they are very noisy, but yeah, it works fine. The bottom one doesn't work, even though it looks maybe even better. I like the darker display, just makes it look a little bit better. We can have a quick look if there is some low-hanging fruits, but I don't feel really like to go into a repair today, so just have a quick look. And make cleaning that stickiness really pays off, because now it's all smooth, it feels smooth, and it looks a lot, just a few shades lighter. Okay, well, that is very easy to try. We just take the first outside, and the outside, well, that should of course just connect. Yes, it does. Then I need to take the outer ring and the outer ring from this one. It seems to connect. Center pin, center pin. No, really, the center pin is really not connected. Then it maybe works if I connect it in the back. Okay, so in the front it is not working. I'm putting 5 volts in the center and the second ring. It's not making too much sense here, but I can't really see. I think I should be good. What does it say? No, also not. Let's try to connect it on the inside, direct on the cable. Well, it doesn't look that well connected. I hope you can see it. Try to move a little bit better. But here are the two cables. And one of the capacitors here is already cut. And the bottom wire that comes from the front seems very loose. Doesn't seem to connect it with the other one. I tried to connect it directly to this middle pin right here. Well, I need to take it apart a lot further, so I will do that another time. But apparently, maybe one of them was in a very vibrating environment, because the connection from the front to the back also was not connected anymore. So I think because of the vibrating, maybe something broke inside. Well, exactly the same could have happened to the other input that actually goes to the input. But then I need to take the whole input circuit, and I really need to take it apart because it was all enclosed in aluminium, and I don't feel like that today. At least I have now the triac BNC to BNC converter, so I can use that on more devices that have these. You will see that usually on devices that need to measure very low voltages or very low currents, and then, well, all the electromagnetic, all the pulses, everything that is around can then influence your measurements. So then you have this extra card that actually protects the cable. I'm not using that right now because I'm just using a normal coax, but you should have used then the extra card, and that protects then for all these little distortions. But I was just measuring in volts, and then it doesn't matter too much. So yeah, clean again, repair maybe another time. Very good choice to have bought two, because then the chance is a lot bigger than that one was working, and it was. So that's good. So thank you for watching, and hope to see you next time.